Good day to everyone and welcome to our session. Today we will talk about the Oracle GPU power, and you will learn how to accelerate Kubernetes and Kubeflow workflows. We are joined by our colleagues Alberto Campagna and Tim Graves, who are here to do this nice session, and we hope that you will find it interesting. And we have also prepared some demos. So Alberto, Tim, would you like to say something about you? Say hello.
Yes. Good morning, everyone. I'm Alberto from Rome. I'm a computer engineer working in Oracle as the application development specialist group. And we deal with everything related to Kubernetes, GPU, DevOps, and all the cloud native space. And together with me today, there is our own personal Santa, Tim Graves.
Oh, hey folks. Actually, I should better go to my day job rather than my highly seasonal job. So, as Alberto said, my name is Tim Graves. I bear a strong resemblance to a certain highly fictional character, very seasonal. But today I'm going to be talking about what we can do with setting up Kubernetes clusters with GPUs and things you need to be aware of around that. And I work in the same team as Alberto.
Thank you, Tim, Alberto. So let's continue with the housekeeping rules. So as some of you, and I hope that you noticed already from the screen, the session is recorded and will be shared with you in approximately 2 days from now. You will get a thank you email from us and the link to the recording. It will be as well posted on the Oracle Developers YouTube channel in approximately 1 day from now. And you will also see it on a page, namely Developer Coaching on Demand, where we host all the sessions recordings. And I think it's really useful for you to bookmark this page. I will share it with you later on chat. And on Q&A, Ettore will open a question on Q&A. And thanks, Ettore, for your help. And we will try to push all the relevant links there, because it will allow you to copy. Unfortunately, the chat functionality does not allow us to copy from Zoom. So here is why we decided to push all these resources links via Q&A as well. For any further information, questions, or any help that you might need from our team, feel free to use as well the email that you see now on the screen, which is contact-tcx-emia_ww@oracle.com. Regarding ways you can interact with us today, there are 3 options. First one is Q&A, which is public. So feel free to not share any private information on Q&A, like phone numbers, email addresses, any of your organization private details. If you need to share something with us, feel free to use chat, because this one is private. Only the host can see your message. And there is also the public Slack community, OCI Tech Community Workspace, where we invite you all to join us. How you can do that? You will see now a link coming via chat. And this is the invite link. You have to register, of course, with your Oracle account and your SSO, or feel free to scan the QR code that you see now on the screen, and it will take you to the registration page. I think this is a great place to be. If you'd like to post questions during this session and also after the event, we will try to push there all the relevant resources, like presentation of this that you'll see today, the recording, useful materials, and many other interesting and useful things that you might need. And if you'd like to keep up with any news and regarding the OCI services or our upcoming events, this is also let's say the perfect place to be. So for today, the relevant channel is the developer coaching events, but keep in mind that there are a lot of other programs we are currently running, so feel free to check what is available there, and of course join these channels. Today we offer the possibility to get more on the Oracle Cloud credits to test our services. So you will get a free tier promo that consists in $500 in free credits that you can use for a 30 days period time. You will get this free tier promo link in the follow-up email together with the recording. What you'll have to do when you do the sign-in is to use the same email address that you used to register for today's event. Otherwise, it will not work. And in case you get some errors or you do not see the promo banner after you do the sign up process, feel free to come back to us on Slack and we will help you. Important note on the demos you will see today. So all the examples we showcase are purely fictive and they are not showcasing any real use case we are currently running. So keep that in mind. I think with that, it was all on my side. Alberto, over to you.
Okay, so thank you all for attending this session and be here. We will see a topic that is very hot today, that is GPU. Everyone is coming to get GPU, and Santa might have some GPUs in his bag, but we also need to know.
I wish I had a budget big enough.
Yeah, GPUs for everyone. But yeah, we also need to understand how to select the GPU, how to train and inference models, and why Kubernetes is becoming the de facto standard for training and infer machine learning and AI models. So let's start. This is the safe harbor statement. This is something required from legal, and this is just something I've done and shown you. So we can actually start. So this is the agenda for today's presentation. Do not be misled by how short it is. There are a lot of contents to cover, and I know it will be an action-packed session. We will start from the bottom by describing the infrastructure used for AI workloads. So at the bottom layer, there is the infrastructure. The next layer is Kubernetes. And here my colleague team will share all the tips and tricks to run OKE with GPU nodes. And finally, we will present Kubeflow in a live demo. So Kubeflow is an open source platform to implement MLOps and better implement a process to develop and train machine learning and AI models. Be warned that there are a lot of concepts to understand in this presentation, as building a platform for AI workloads is actually quite challenging. Me and team will do our best to explain the basics, but time is always an issue with this, and we may not be able to cover all. In case you want to know more and you are interested in the topic, feel free to schedule a booster call later with all of us. So let's start our journey and talk about the infrastructure for AI. So AI infrastructure is something a bit different than the classic infrastructure. And the first thing we need to understand is that there are multiple GPU shapes available in OCI. And in order to select one, it's important to understand the model size and complexity for the model that we need to deploy and train. For small, medium-scale training and inference, there are A10 and L40S GPUs available. But if your model is really complex and it actually occupies a lot of memory, you will probably want to look at H100 or the new H200 NVIDIA GPUs. So the Tensor Core H100 and H200 NVIDIA GPUs. But just having the right GPU is not enough when building an AI infrastructure. We also need to define what kind of storage and network we will use. And for storage, one thing that is widely used in AI is the OCI file storage service. that is a managed NFS service, so a network file system service, that can reach a throughput of up to 80 gigabit per second with a high performance mount target. In the future, there will be also managed last service that is a storage solution very, very widely used in the AI space. But let's come to the network. And while the network might seem an irrelevant detail, maybe it's not that true, because right now there is a lot of focus on GPUs, but maybe not enough on network. So is network really irrelevant? And what exactly is an RDMA network? We'll uncover the details of this in the following slides. So RDMA stands for Remote Direct Memory Access, and it's something very widely used in the HPC world. But to understand this, let's look at an interaction between two nodes that wants to exchange packages in a network that is without RDMA. So in this exchange, the sender is sending some packets and the receiver wants to receive the packet. And the receiver kernel must receive this data. Then the kernel in that node must determine that the data belongs to that application, that is the receiver application. And then the kernel needs to wake up the application. And then the kernel needs to wait for the application to perform a system call into the kernel, that is application saying, I'm alive, I'm ready to receive packets. And then the application needs to copy the packets from the kernel space to the application space. You see, there is a lot of interaction between the kernel and the application space, but the objective of the RDMA is to bypass the kernel so that communication happens only between the application stack. By doing this, what we can achieve is a very, very high performant and low latency network. Consider that in clustered network, the latency is not milliseconds, but we are talking about microseconds latency. And in Oracle, what we propose is ROCE, that stands for RDMA over a converged Ethernet network. So these networks are gaining a lot of traction in AI because they are very reliable and very low latency network. But why is network important? Why should we have this low latency network? So scaling a server vertically is always expensive, and we will eventually hit a limit. For example, in OCI, most of the GPU shapes come with 8 GPUs, without the possibility of adding more GPUs to the node. We will eventually hit a limit of how vertically we can scale, even from a memory perspective of the GPU. And if the model that we want to train is very large, that could be a problem. And it's probably better if we find another solution. And that solution is distributed training. That is a technique to train very large models over a cluster of machines. That is a clustered network. We use the divide et impera approach, something that is very common in the computer science world, that divide et impera is Latin, and it stands for divide and conquer. And there are 2 strategies to divide. If the dataset that we want to train our model to is a very large dataset, what we do is we deploy the models on each clustered node, the same model, but we split the dataset into multiple datasets so that at the end we can train the model and have in a faster way over a reliable network. And then another approach, if the model is very, very large, then we have no choice but to split the model to the various nodes. So we have model 1, 2, 3, and 4 deployed on 4 different nodes, and we keep the dataset the same. In both cases, the nodes need to cooperate over a reliable and low latency network. And when it comes to distributed application, because at this point, this becomes a distributed application problem, well, Kubernetes is probably the best platform for the job. And that is why Kubernetes in general is gaining more and more traction as the platform to run AI workloads. And to uncover the secret of how to run AI workload on Kubernetes, today we have got Tim, who has got a lot of GPUs on his bags and ready to give his advice on how to run AI workloads on Kubernetes and OKE. Cool, Tim, over to you.
Thank you, Alberto. Let me just share my presentation. Okay, hopefully my presentation is visible to people now. Somebody could just wave, Alberto. Yep, excellent. Okay, right. Thank you very much for the introduction, Alberto, and for that very good start. When I'm not very, very busy on one day a year, I tend to talk about Kubernetes with the same team as Alberto. And today what I'm going to be doing is I'm going to be talking a little bit about some of the benefits and the reasons you're going to use Kubernetes, and also some of the things you need to be aware of when setting up a Kubernetes cluster for AI machine learning workloads using GPUs. So, to start with, as Alberto said, Kubernetes is very heavily used in the AI space. It's actually heavily used across many types of workload, although a lot of them are AI-based, as we're going to see in a minute. Now, critically, Kubernetes brings you a lot of things that you need beyond just the core of that AI machine learning engine, okay? Because you need to have things that wrap around it. So we offer, as do all managed Kubernetes services, a fully managed control plane. That means you don't need to set up the Kubernetes environment yourself. And we'll see in a minute how we can make that process easier. This means that you can focus on what your applications need to be doing and therefore increase your agility, flexibility, and scalability rather than having to do all of the work of managing it and bringing it together. Now, you can choose what type of processing you want to do. Obviously, for AI ML applications, you're probably going to be using GPUs, for example, NVIDIA. However, as I said before, there are things that you will also need to be running. You may not be using GPUs for serving those applications, for delivering them. So you may be using Intel, AMD, or ARM to do that process. And with a Kubernetes environment, the goal here is to help provide that easy to use environment and shrinking that cost of ownership. So you're only using what you need. Now, it's possible to deploy truly massive clusters of CPUs and GPUs. We have customers who are using thousands of workers at a point in time, and that number is growing. We're looking to take that up to 5,000 or more. Also, Kubernetes provides a lot of automation, and in conjunction with things like Kubeflow and Nextflow to automate that process, it can minimize human error and obviously reduces things about risk around compliance and stuff like that. So, as I say, it is the platform for machine learning workloads. A couple of years ago, it was still running about 65% of those workloads were machine learning, and that number has probably grown since then. You're obviously 3 stages here. There's the development of a model. This is like the programmatic part of it, where a human actually does work. Then there is the training of a model, and this in particular is where RDMA and high GPU clusters are used a lot. Then there is also inference, serving the model, and that is a lot smaller, because the model, once it is built, is generally just regurgitating data, so you don't need all of that. Sometimes that's going to be GPU based, sometimes it's not. And that is particularly an area where the scalability of Kubernetes is important, whereas on the training, it's the ability to run all of these workloads and do all of that workload management. Now, just to be clear, Kubernetes and Oracle Kubernetes environment in particular is something that is critical to Oracle. We're very good at this, and the reason we're very good at this is because if you look at our cloud services, over 100 across the SaaS and PaaS areas run on our Kubernetes environment. If we weren't good at running this, realistically, we wouldn't be able to deliver our cloud services. All of our Oracle AI services run in Kubernetes. And the reason we've chosen Kubernetes for that is the reasons I just mentioned, that scalability, that flexibility, that ease of use. that ability to share and balance resources. But we have many thousands of customers who are using many millions of CPU and GPU cores in Kubernetes as well. Now, we offer a range of processing types within our Kubernetes environment, and you need to choose the one that makes most sense for the application you are doing. Now, one of those, which you'll see if you look at our Kubernetes environment, is virtual nodes. That's not relevant to machine learning currently because it doesn't have built-in support for GPUs. However, we do have two options that are directly relevant. So managed nodes is where you define what you want those workers to look like, and then we will create them, set them up and manage them, and we'll handle things like dynamic scaling. This is really good for serving AI models because it means you can dynamically scale according to the load you want. However, for building AI models, for the training aspect, people obviously have a very specific set of customizations and viewpoints that they want regarding the exact configuration of those environments to make it most efficient for their application and their model building process. And in those cases, we offer self-managed nodes. This is particularly useful because it allows you to set up things like RDMA networks. Now, this gives you a lot more control, but it's not quite as easy to use. Now, let's go and talk about self-managed nodes because I say they're mostly used for training. In this case, basically, you create a set of workers. We have automation to help you do some of this, but you create them outside the Kubernetes cluster. You can use instance pools or instances directly yourself. And there are certain limitations that come with the more automated environments that you don't have in this environment. For example, the RDMA cluster environments. Now, you can then apply labels and taints to ensure that the processing gets run in the right node. And I'm going to talk in more detail about that in a minute. We can also generate mode metrics, and you can use the workload management tools. Once you've got those set up, you then introduce those into your managed Kubernetes cluster as resources to have compute jobs run on them. Critically, we also support Ubuntu. Now, Ubuntu is pretty standard. It's a very popular Linux distribution, and it is widely used in the AI environment. Now, we do have Ubuntu-based images. They're not showing up currently in the drop-downs, but you can build workers using those Ubuntu images. And of course, for a self-managed worker, you're effectively building a custom image. So you can build that on Ubuntu if you want, and then you can use that in those workers. Now, let's talk about some of the things you need to be aware of when setting up a Kubernetes environment and using GPUs. Now, this is based on a lot of conversations we have had with customers around EMEA, but the principles are obviously applied worldwide. So, a couple of things. If you're using a managed node, then we support most of the GPU options. As I say, managed nodes is more for delivering and serving the models, but you will need to use a GPU-based starter image. So that's basically an image that has all of the GPU drivers, all of the resources, as being configured for optimal use with GPUs. When you come to choosing a worker for a serving operation, you currently don't use virtual nodes because, I say, those don't support GPUs. You're more likely to choose a managed nodes. For a training operation where you're using self-managed nodes, let's say you're going to want to use RDMA. In that environment, again, you would probably use a GPU-based Kubernetes starter image because that will save you doing a whole bunch of standard installs and work. And then you will do the customizations, usually in the Cloud Init script, or perhaps you want to build your own worker node with your own drivers and stuff like that in it. Okay, and then that's the image that you would use for the self-managed nodes. Now, you've got to choose the right workload on the right cluster. Depending on what you're doing, you may want to mix and match both the training and the operational delivery side in the same Kubernetes cluster. Now, you've got to be really, really careful here, because even if you're not doing that, you're still going to be running applications that run the cluster and help you manage the cluster, but also the application that runs your training environment. So you need to ensure that the applications run on the right worker. You don't want something running on a GPU worker if it doesn't need GPUs, because that's using those resources. Now, Kubernetes can help balance that. You can allocate GPUs and so on, but it's still a efficiency thing, and therefore that is a cost thing. Now, in Kubernetes, there is support for things called taints and tolerations, labels and affinity that help you do this targeting process. A taint is basically something that keeps things away. It's effectively like a bad smell. It makes the processes go away. They don't want to get involved here. But you can override a taint. Obviously, in case of a smell, you can put a nose clip on your nose. Not a good idea, but you can do it. In Kubernetes, what you would do is you'd use a toleration that will override the taint. So we strongly recommend that if you are using systems with GPUs, especially self-setup systems, that you apply a taint that will push away all tasks that are not GPU driven. Equally, you can attract tasks in Kubernetes with labels. So this is something that's attractive. It makes people want to be there. And you can bring those into place using affinity, and in particular, something called a node selector. So those combinations can be used to keep things away from GPUs that shouldn't be on GPUs, and to draw things to, let's say, administrative tasks that don't need GPUs. And of course, the reverse is true. It keeps administrative tasks off the GPUs, and it keeps keeps GPU tasks off the administrative functions. Okay, because obviously you want to use those GPUs. Now, these are examples of how you would do this. You'll be able to see the details, obviously, when we send the slide out, but you would normally define a resource that says to Kubernetes, I want to run on GPUs. So that's part of your resource limits. In this case, it's saying I want to run on one GPU. You'd set a toleration that allows you to do that override. In this case, you're saying if the toleration API apps allowed exists, then it overrides that no schedule option. And also you would set a label or a node selector. For example, node selector type application means that your applications, your management functions will try and run on those environments that have been set aside for applications. We recommend you split your workloads at least into 3. You've got the system workloads, for example, the Kubernetes dashboard or ingress controllers. You've got your application, things like Kubeflow management, Nextflow management, and then the GPU tasks. And where you are using a managed node pool, use that to configure the system and applications, because it's going to make life a lot easier for you. Now, GPU apps are often more of a batch job than a microservice, especially for things like training. Delivery is slightly different. That is often controlled by something like Nextflow or Kubeflow, a job manager, and those jobs can be long-lasting. For some types of job, it actually makes sense to use preemptible resources because they're much cheaper, but you run the risk of those resources being taken away. Now, in that case, you may not be using a full RDMA cluster. You will probably use a managed node and you'll use the cluster autoscaler. But if you're doing this, think very, very carefully, because on managed nodes, if we take a worker away, you need to decide what you're going to do to the jobs that are running on it. Do you restart those jobs? Do you throw the work away? Does the job manager understand the concept of things disappearing and reappearing? So you need to be careful there. But you can save a lot of money for certain types of training with preemptible nodes. Also, when you're using GPU workers, just be careful, because if you hand a worker back to Kubernetes, for example, you're doing an upgrade on the software that you've got, because if that's installed into the image, you may find that you're handing it back into the OCI environment. You can lose resources. There's a huge demand for GPUs. Somebody else may come in and take that GPU whilst you're getting ready to set it up. So we recommend, instead of taking a number and going below, hand one back and then requesting a new one, but you request the new one first, and then once it's up, you hand the old one back. Therefore, you're surging rather than dropping below. Also be warned that for bare metal servers, it can take a while to do a reset. Now, you will be running in a tenancy within OCI, and tenancies have limits, and usually for GPUs, that is a low limit. You will probably want to request an increase in the number of GPUs you are allowed to use. To ensure that you have those GPUs available, especially given the current very high demand for GPUs, you may want to make a capacity reservation. Now, there is a cost for that, but it does mean that once you've got that, those GPUs are allocated to you and nobody else can use them. If you are going to use the cluster autoscaler, make sure you choose the right GPU shape. I would recommend virtual machine shapes. They're much faster to provision and reset. Therefore, that's saving you money. But also, things like the VM shapes are a lot easily available. They can work with a cluster autoscaler and dynamically scale, and that's going to bring you significant benefits if you are serving the model. Now, other things you need to consider. AI applications and containers are big, right? Typically, you may see a few hundred megabytes in a container.
in a GPU AI application, that can be a few hundred gigabytes. So you need to think very carefully about the sizing of the workers, because you need to store that image. You need to be able to run it and decompress it. So the models are usually held within a container, especially when you're serving, but even if you're training, you're usually starting with a base model. Therefore, you need to think carefully about this. If you take a big container and put it on a small ship, or in this case, a small worker, it will not fit. And that can cause problems. You may find that other processes, other tasks get kicked out and that processing is stopped, or you may find your container just isn't able to start at all. Now, obviously the solution here is you use a bigger worker image, and pretty obvious, but you do need to remember to set that up. By default, we go for 50 gigabytes. You need to go for bigger in many cases, and you'll need to grow the root file system. Also, as I say, the containers are big. You need to think where you're going to store that container. If you store it in a public resource like Docker Hub or GitHub, you are talking a slow connection to talk about. Now, slow is obviously relative, but in practical terms, you are accessing that at internet speeds rather than local speeds. Also, that means in addition to the slow performance of retrieving stuff over the internet, those services often, especially in their free models, throttle the data throughput you can have. Now, I've had a customer and literally they were doing AI work. In this case, they were serving a model and they were taking over 20 minutes to download their data. That's painful. Now, that meant that every time they wanted to do something, they had to wait every time they wanted to scale up, rather, they had to wait 20 minutes for the container to be downloaded to those new workers. What you need to do is you need to run it locally. We offer a service called OCIR, and that is running over the backplane. So you're talking tens, possibly even hundreds of gigabits of throughput here. It's not infinite, but it's pretty big, okay? So in that case, for that particular customer, their time to download the container image and start the model was just about 20 seconds, okay? So that's a 60-fold improvement in startup performance. So thoroughly recommend that. I'm not saying this for revenue purposes because we don't charge for that service. We only charge for the storage used, but just be aware that will make a significant difference to you. Now, when you create a Kubernetes cluster, you can, of course, create them by hand. We recommend the use of Terraform. There's a Terraform module. I've got a QR code that hopefully links to it there. This module can actually set up managed workers as well as all of the other elements in your Kubernetes cluster, and it follows OCI best practice. Please, I strongly recommend that you use this. Creating a Kubernetes cluster is a complex task. You have to get the networking set up right, as well as all of those workers. So this will make your life a lot easier. So with that, that's an introduction to why you would use GPUs with Kubernetes, why you'd use it with OKEs, and how you configure those environments. So back to you, Alberto.
Thank you, Tim, for the well-detailed explanation. Really, really great job. And I'm afraid we have yet to see a little bit more of theory before starting with practice, but bear with me. It's just a little bit small theory on about Kubeflow, and then we will show the cluster and how it's done. So Kubeflow is just one of the open source platform you can use to run and manage the life cycle of AI and machine learning workloads. We are presenting Kubeflow here because it's open source and it's rather easy to install. And as I said, developing an AI platform for data scientists on Kubernetes is quite a daunting task. And the beauty of Kubeflow is that it automates all the creation of the various components. And if we see the Kubeflow components, this is the architecture. So you can see Kubeflow is not just one application. It's actually a set of applications to automate the entire release cycle of machine learning and the AI workloads. So it covers all the steps of the MLOps flow. We've got data preparation because we models are trained on data, so data needs to be prepared in order for the models to use that data. And for that, Kubeflow has a Spark operator running inside Kubernetes. Then we got the notebooks, and we will see notebooks. Notebooks grants the data scientists the ability to have an environment where they can safely develop their model and then push the changes to production. Khatib and the training operator are used for training, and we'll go a bit about the training operator. We'll see a bit of the training operator. And then Kserve is used for inference. So once we have our model trained and we've got our artifact stored in the model artifact, then it's time to provide users with an endpoint so that we can share the model and user can actually use that model. And of course, then all this process needs to be repeated. And for this, there are pipelines, and pipelines are like a glue that put everything together. So we train the model and then we deploy it to an inference server. These are the components of Kubeflow. About the training operator, where I've seen use this is for MPI. And MPI is a specification for exchanging messages on parallel computing architecture. It's something that was very used in the HPC world, in the high performance computing world, but with the recent introduction of AI and the boom that AI has had, we have got we've seen a huge increase in this specification, and this is used for distributed training. So again, we go back to distributed training and the first slides I presented. And this operator helps define you MPI jobs in Kubernetes so that they are orchestrated and you can run or reduce style training with MPI. Then, okay, we have seen how to train it, to train the model, and then we need to infer the model. And for that, there is Kserve, that is a serving serverless platform that runs on top of Kubernetes for serving predictive and generative machine learning models. And this slide a bit summarize all our journey that we have done today. So we've started from the infrastructure, CPU, memory, GPU, storage. We've seen Kubernetes, OKE, and then now we're seeing the most abstract layer. So all the serverless inference, so Kserve and Kubeflow as a platform. But yeah, to better understand this, it's probably better if we go right straight to the demo and the live demo. So again, we start with the infrastructure. So this is my tenancy here, and I've got my OKE cluster already installed, as it takes a while to create a Kubernetes cluster. So you can find the OKE service under developer services, container and artifacts, OKE cluster, so Kubernetes clusters. Here it is, my OKE Kubeflow cluster. You might see something blurred here, but this is just for privacy reasons. I've got a script that blurs. So don't worry, it's just an effect on the screen. So the beauty about having OKE is that the control plane is fully managed by Oracle. So you don't need to manage the control plane. And the control plane is usually the most critical part of Kubernetes. The only thing you need to take care of is the data plane. So all the nodes that are in the infrastructure. You can group nodes by node pool, and node pool are just a logical group of nodes. So if we try here to add a node pool, we can also select different shapes per node pool. And one of the shapes, and the cool thing about OKE is that you can also have bare metal shapes directly supported in the node pool API. So if I need an A100 NVIDIA shape on a bare metal machine, I can have it, and I can have a mix of virtual machine and bare metal GPU shapes under the same cluster. For our demo, I've just spin up 3 nodes. We don't have GPUs. I've been a bad guy, so Santa hasn't given me any GPU. But it's important for you to understand that you can try Kubeflow and even run AI model without having GPUs. So the exact same thing, this exact same setup, you can have it on your tenancy by using normal CPU shapes like AMD shapes. So it's actually good because you can try the Kubeflow and you can try OKey. Okay, so this was for the infrastructure, and let's go a little bit at a higher level. The next thing is to install Kubeflow. Once you've got the cluster, you can access the cluster through here. You can copy the kubeconfig, the command to create the kubeconfig, and then you can connect to the cluster. There are there is a lot of documentation on how to do this. Once you've got the connection to the cluster, we need to install Kubeflow, of course. So the Oracle DevRel organization has a script for Kubeflow on OKE. And yeah, if possible, I will send also in the slide this link. So you might see that the version is stuck to the 8.1.1, but actually Kubeflow is on version 1.9.1. And I've tried it. I haven't found any issue. And the good thing about this is that you can take inspiration from this repository to deploy your own version on Kubeflow and customize it. In fact, if you see, there is a file called install kubeflow.sh. In this file, you can take inspiration and modify it to deploy your own version of Kubeflow in your cluster. And if we see what this script is doing, is just cloning this repository, Kubeflow manifests. And this is the repository where Kubeflow has all the manifests to install it on the cluster. So let's see, it is this repository, so Kubeflow manifest. And you can go into the example folder, and there is a customization.yaml that is, let's say, an aggregator for YAML resources that are customized. And you can choose what resources you want to deploy on the cluster. So depending on what you have installed on the cluster, you can comment or decomment this. And just by running this customization, you will have Kubeflow in the cluster. You might think it's easy, but there are some tips and tricks. And one of the tips and tricks that Tim also provided us, and is again in the Kubeflow OKE repository, is a cloud init script. So if you're using Oracle Linux 8 nodes in the OKE cluster, you need to have this cloud init script for Kubeflow, because there are some modification that needs to be done to run Istio, and there is also a known bug. So Team, our own personal Santa, provided us with this script so that you can insert in the node pool. You can go into the node pool here, edit, click on show advanced option, and you can pass that cloud init script here, and then the nodes will be created using this cloud init script. So this is actually a prerequisite at the infrastructure level to run Kubeflow. And then my suggestion is just go to the manifest, just clone this repository and customize the YAML so that it fits your cluster. I've done the same through my favorite IDE. So I've cloned the repository and the manifest for version 1.9.1, and then I've customized it. Like, for example, I didn't need cert manager, and then I commented cert manager. I wanted to install Istio, and I left Istio as an install, and so on. What is important to customize here, especially if you want to expose Kubeflow, is the service. So there is a file, there's a file that where you can customize the service so that you can change the service from type cluster IP to load balancer. And every service of type load balancer will create a physical load balancer in OCI with this reserved public IP. So you customize the load balancer through annotations. You specify the IP that you want the load balancer to have, public IP, and you specify that the service should be of type load balancer. And then at the gateway level, I specify that I want my DNS name that will resolve to this public IP to be this one. Another thing that I've noticed, especially in the most recent version of Kubeflow, is that there is a small modification that needs to be done on the ML pipeline UI deployment. By default, and I don't know why they have chosen to do so, there is this disable GKE metadata set to false as default. This means that this microservice will not work unless it is deployed to GKE. So you have to go into here and set the value to true. This is the only issue I've experienced with the latest version of Kubeflow. And then if everything goes all right, we will have our own Kubeflow installed on OKI. So this is the look and feel of the Kubeflow platform, and you can see all the components, the pipeline, the Kserve, the Ktib, the notebooks, all the components that were in the architecture slides. Usually, data scientists do not want to deal with infrastructure, so everything should be as transparent as possible. Usual data scientists would just log in here, go into the notebook session, and then it will click on the new notebook. So we are just creating a notebook containing our Jupyter Lab environment. I would say dev coaching, specify the amount of CPU. Let's put it 2 and 6 GB of RAM. It's quite a small cluster, my cluster. And you can also attach GPUs to the Jupyter Lab notebook, but we don't have any GPU for now. So see, there are currently no NVIDIA or AMD GPU. So I will just set it to none. This notebook will also have a persistent volume. So it will create a new volume called Dev Coaching Workspace. And that's it. Then I can launch it. So while the interface and the infrastructure is completely transparent to the data scientist, the thing that is doing Kubeflow now is spinning up a pod with a volume inside my cluster. It takes a while because it needs also to download the Jupyter Notebook image. And you can see here that we have 0 GPU, 2 CPU, and 6 GB of memory. And at the same time, a volume is also created. So the minimum size is 50 GB with read-write once with the default storage class. And this notebook will contain all our workspace. Always take a while, but yeah, it's green. So once it's green, we can connect to it. So we can open up sort of port forwarding connection, and I've got my Jupyter Lab notebook. From here, I can have a terminal. So I can start a terminal, I can git clone a repository, and I can create my Jupyter notebook to train and develop my machine learning model. Then again, this is for the notebook. We also have pipelines and pipelines are the glue to everything. And just to show it, the look and feel, will run the default one of the default pipeline that Kubeflow has. It is data passing in Python components. So this is a predefined pipeline. Oops, sorry. And there is a preprocessing done on the data, and the data set is split into two data sets where we perform the training, and then from the training process we have a final model. So this will not deploy to the model to Kserve, but it's a good way to start and let's say demo this Kubeflow service. We can create a new run. We need to choose an experiment where we want to run our own pipeline runs. So use this experiment. This run type will be a one-off. We can also set recurring pipeline that will recurrently train a model. And then we can also define some run parameters, but I will leave it like this and then start. And again, in the background, at the Kubernetes level, there are some jobs that are spin up for this pipeline. And yeah, the pipeline is running in Kubernetes. So it takes a while, of course, because it's a pipeline, but it's a very, very simple script. So it means we are not doing distributed training of large language models or anything. At the end of the pipeline, we will have the data set. We can inspect the artifact, and all the artifacts from the data set and the final model, the final training model, they are stored in min.io. So they are stored in a block volume inside Kubernetes. I've got this error, but it's not something very clear to me why I've got this. It's not actually an error, it's just a warning. I don't know why I've got this. But if I actually click on the min.io, I can download the model that the pipeline has trained. But yeah, this is very common with all this AI tooling. I can tell you from experience from other POC with customers, most of these tools are actually in the alpha stage. And that's why there is a lot of, let's say, space to improvements for AI and AI platforms, because everything is very new and very unknown. And that's also why we have run this workshop. So I think it's all. That's all. I don't know if there are questions open. Okay.
There is one. There is one that is open, and let me quickly. I see that Tim wanted to answer live to the one about what are GPUs, so I will leave that to Tim. And there is another one from anonymous attendee. Can Kubeflow be used for inferencing?
Yeah, I will answer that.
Purposes as well. Yeah, inferencing. Yeah. All right. So.
Okay. So just on inference, yes, Kubeflow can be used for inference because it has Kserve as a component. You can use Kubeflow as a platform, or you can just simply install Kserve on any Kubernetes cluster and run inference through Kserve. What Kserve does is it pulls some of the most common inference server, like Triton, for example, and it will fetch the model, the trained model from the min.io or a bucket, and and run that model on a pod with the inference server. So yeah, it can be run.
Thank you, Alberto.
And regarding the GPU question from Otis, GPU stands for graphical processing unit. And the reason I decided to answer this live is people say, well, why does you use GPUs for processing AI? The reason is both rendering live videos, if you like, and gaming and all the rest of it, but also AI are what's called embarrassingly parallel. So that means that you can do many, many parts of a task spread at the same time. So historically, yes, GPUs were based on drawing triangles and rendering stuff on a screen, but it's also used because of that embarrassing parallel capability, which is why we talk about GPUs. We should probably find a better name for them. They should be AI engines or something like that. Maybe in the future they will be, but for now, unfortunately, they're still called by their old name of GPUs. Just quickly looking on, so somebody's asking about running Kubernetes using the HPC cluster. So the high performance clusters that we offer, I think those are actually based on Kubernetes. So effectively, you are using Kubernetes when you get access to that high performance compute service. Alberto, do you want to answer Marek's question?
Yeah. So yeah, Marek, I haven't seen any performance degradation when using Kubernetes, especially with Slurm. Actually, some people, and I've got a POC running, have used Slurm on an RDMA network, and they've seen even better performance. But usually there is no performance degradation. Containers are very similar to processes. It's just and Kubernetes is just a way to schedule those pods on the underlying infrastructure. That could be also on some self-managed nodes on an RDMA cluster.
And in fact, you can actually use Kubernetes as a compute resource with Slurm. I have a customer who has a Slurm application. They have their own HPC cluster, and they use our Kubernetes environment as kind of like an overflow. And that's where they use all of the dynamic scaling. So Slurm just goes, run out of space there, schedule it into Kubernetes. Kubernetes goes, okay, I'm going to scale up and start running those tasks.
Thank you to both of you. So I know we are a bit over the hour, so I would like to use this moment to ask the audience what you would like to see next in the developer coaching events. So have a look on the options. Keep in mind that we usually build these events based on your needs. So very important to vote here. And whatever you voted today, one catch here is that we usually build these events way in advance. So whatever you voted today, you will be seeing in, let's say, January, February timeframe. So it will not be there in, let's say, next week. But we read all these answers and we try to showcase the most voted topics from our customers. So let me quickly see which one was voted the most. I see AI and app innovation. I think it was voted the most so far. And oh, sorry, I'm on camera off. All right. So I would end the poll now and quickly share the results. And as I said, you would like to see more on AI and application innovation. The second one is run OCI AI infrastructure. And I think that was all on the polls. Many thanks for taking the time to vote. So to wrap up the call, there are two places where you can find information. Actually, there are three places where you can find information regarding our upcoming events. There is the free developer coaching events page. There is the Oracle Developers page, you can go and register. And there is also the Slack community where we invited you all to join us. Here you will see a lot of news and messages regarding how to register to our events. If you check now the developer coaching events channel on OCI Tech Community Workspace, you will see a message coming from me, which says that the Boost events are opened, and feel free to reply on this post and ask for it. As Alberto said at the start, we covered complex services today and a lot of information. So if you need further help or further information from our specialists, then feel free to ask this private call. We offer 2 20-minute calls, first come, first served. So the first 2 customers who will reply to the post will be contacted by either me or anybody or anyone else in the team, and we will try to facilitate this event for you. Important note regarding these Boost events is that they should not replace any of the current workload discussions that you might have, and they are not meant to be a support call. Very, very important for you to be aware of. This is a page, and I shared it with you via chat and Q&A. This is the AI Solutions Hub page where you can go and find a lot of real world scenarios, scripts, videos, source codes, tutorials, a lot of options that you can leverage and can use if you'd like to learn more about our AI solutions. Feel free to bookmark this page and see what are the possibilities there. Here is another slide with a lot of other materials and documentation available for you. As I said, a copy of this presentation will be available on Slack today. And if you cannot join us on Slack, but you'd like to get a copy of the slides that Alberto and team presented, feel free to ask via the email address that you see now on the screen. Let me quickly see if there is something else we need to cover. I think it is not. Many thanks for answering all the questions. As I said, for everybody here, if you need further help or if you have any other questions, feel free to go to Slack and ask for it. Alberto and team, and also our team are there to help you. Alberto, team, many thanks for joining us today. Many thanks for the great work you have done. We hope that our customers enjoy it. Many thanks to all joining us today. We hope to see you soon in the next one. And there is only 2 sessions left for this month. So we hope to see you soon. Bye-bye and enjoy the rest of the afternoon.
Merry Christmas.
Merry Christmas.